Hi everyone, welcome to my UPSC Civil Service preparation. Okay, in this part of the video, we'll discuss about geomagnetism and paleomagnetism. Okay, in next few minutes, I'll tell about the paleomagnetism, before which we need to know certain basics things. Okay, for few minutes I'll share what is geomagnetism. Okay, we all know that the Earth behaves like a magnetic dipole, so it possesses certain magnetic field. Okay, this is Earth. Okay, it behaves like a magnetic dipole. It has a certain magnetic field which is called as magnosphere. These magnosphere protect the Earth from the gamma radiation. Okay, magnetic field protects the Earth from gamma radiation. And certain magnetic properties is that the magnetic field will have north pole and south pole. This magnetic north pole, geomagnetic north pole, will be towards geological south pole. Okay, so this is magnetic north pole. So magnetic south pole will be near to geological north pole. Okay, so this magnosphere extends to up to 60,000 kilometer. Its range is 60,000 kilometer. Next, there are two attributes: angle of declination and dip angle. We know that if this is the Earth, this is, suppose this is the magnetic axis, this is the geological axis. The angle formed between the magnetic axis and geological axis is called as angle of declination, capital D. And the angle between the magnetic axis and the planar surface at any place on the Earth is called as dip angle or dip angle. Okay, angle of inclination. That is the magnetic axis forming the angle with the plane surface of the Earth at any position on the surface of the Earth. So the characteristics of this magnetic field is fluctuating intensity, reversal in polarity, van pose, which we'll discuss in the paleomagnetic part. The theory is that the Earth will have different layers, among which the core is the one. The core of the Earth contains iron. Okay, the outer core of the Earth is in liquid state. Okay, which contains electron. As these electrons will be present here. As this Earth rotates about its own axis, these electrons also rotate. This electron will give rise to electrical field. Okay, which in turn give rise to magnetic field. So which intensifies electrical field, which intensifies further magnetic field. This is called self-sustaining dynamic mechanism. Okay, this is with respect to geomagnetism. Now let's discuss about paleomagnetism. Okay, I have done notes. I'll share in the link description below. Okay, so what is paleomagnetism? Let's come into that. Okay, in Earth, when the rock is formed, such as igneous rock on cooling of the magma, it gets magnetized in the direction of magnetic field present at that time. Okay, suppose this is Earth, the magnetic field direction is this one, and the igneous rock formed on the Earth will be magnetized in this direction. It will be this attributes, that is, these characteristics will be stored in the rock. That is, preserving magnetism in the rocks is called paleomagnetism, the magnetism which is present in the old rocks. Okay, so now we need to find out the magnetism, for which we'll consider the process as magnetic reconstruction. And we also know that the magnetic poles, the geomagnetic poles, are wandering. Sometimes it is here, sometimes it is here. Okay, the north pole, sometimes it is here, sometimes it is here. So we need to find the position and why it is wandering, for which we'll do paleomagnetic reconstruction, which can be paleomagnetic reconstruction starts with collecting rocks of same age. Okay, if you want to find the polar, that is geomagnetic pole position of that particular time, collect the rock of that age from different location. Okay, so using magnometer find the paleomagnetic dip angle. Okay, so using paleomagnetic dip angle we find the latitude. Okay, once we find the latitude of that particular rock, we can find the distances of poles. okay, at that particular time, not this time, at that particular time. Okay, when the distance of pole is found, the direction also can be found using declination angle using mathematical calculation. So once these both are found, we know that the polar positions. So suppose geomagnetic poles are here with respect to this reading. So we found the polar position, okay, but we know that study has concluded that magnetic poles are wandering. We need to find how. So this can be done by collecting rock samples of different ages from different continents. So two inferences can be drawn from this. The poles are stationary, continents and oceans are moving, or poles are moving, the continents and oceans are stationary. So when the rocks of different ages are collected from the different continents, we need to do paleomagnetic reconstruction, and we need to draw the polar wandering curve. So suppose a polar wandering curve is the curve connecting different polar positions. Okay, if the polar wandering curve for different continents are same, then the continents are not moving. That is, continental drift theory is not true. If the polar wandering curves for different continents are not same, then the continental drift theory is true. So the continents are moving, so therefore which will influence the magnetic position also. So this is what the wandering of magnetic poles is with respect to paleomagnetic reconstruction. Okay, so now let's go to reversal in magnetic polarity. Okay, we know that 50% of the rocks present in the earth are magnetized in the opposite direction. We need to know why. Okay, so this can be done when the rocks might have magnetized in the same direction over a period of time. Suppose the rocks might have magnetized in this direction. Over a period of time, these rocks might have changed its direction. Another point is all the rocks might have magnetized in one particular direction. Over a period of time, the magnetic field direction might have changed. Okay, two possibilities, among which the most favored argument was B. Okay, these are with respect to geomagnetism and paleomagnetism. Okay, these are my notes. I'll share my notes in the link description below. Okay, this is with respect to geomagnetism and this is with respect to theory. Okay, I share the notes PDF in the link description below. Okay, this is with respect to paleomagnetism. Okay, this is with respect to geomagnetic field of opposite polarity. So if you have any doubt, please let me know in the comments. If you like the video, please like, share, subscribe. Okay, I'll be making video for all other concepts. Okay, please hit the subscribe button. Thank you.